Okay, so today I'm going to explain a problem for AP Physics 2. It's problem 2014, number 28. And the problem says that a group of students collected data using a lens. They varied the distance SO of an object from the lens and measured the image distance SI. The figure above is their graph of the inverse of the image distance as a function of the inverse of the object's distance. And the question is, what is the magnitude of the image's magnification when the object is placed 2 meters from the lens? So the algorithm we are going to use, usually you'd be using the ray diagram for optics, but since there's changing SIs and SOs, I just decided that we should just stick to two equations. One equation that we're going to be using is the main equation, is the magnification equation, because that's how we're going to actually solve for the magnification. The other equation that we're going to need to use is the focal point equation, which is 1 over SI plus 1 over SO equals 1 over F. And since we're solving for the magnification, the focal point is staying constant, we were able to plug the numbers into these equations to solve for SI, aka the distance of the image from the lens, and then M, which is the magnification. We do not need to create a ray diagram because it's not helpful. So for the very first thing we have to do to solve this problem is we have to find the focal point by plugging into the equation below by using the values from the graph. I just chose the easiest point on the graph, which is basically where it, just completely, there's no guesswork. We know that the SI is at 1.5, and we know that the SO is at 0.5, or 1 over SO and 1 over SI, since it says that on the side of the graph. Since that's already given, we are able to just plug it in. 1 over SI is going to be 1.5, and we're going to add that to 0.5, which is 1 over SO, which equals 2, which is 1 over F. So that means the F is going to be 1 over 2. So that's our focal point, is 1/2. And then now that we know the focal point, we can plug it into 1 over F, and 1 over SO is given to us at this point, which is 2 meters. And we can plug both those numbers in to solve for 1 over SI. And then we inverse the answer to find SI. So we plug in 1 over F, which is 1/2, and we have to subtract SO in order to find SI. So we go 1/2 minus 2, which is equal to negative 1.5, and 1 over 1.5 is equal to 0.666667. So that means SI is equal to 0.666667. From there, since we know SI and SO, we were able to just plug it into the magnification equation. Using the SI that we just solved for and the given SO, we can divide to find the magnification. So it's basically just SI over SO, which is 0.66667 over 2, which ends up equaling 1/3, which is A in the problem.